So here we have a finite geometric sequence. Remember, the word finite means that it ends. It doesn't go on forever. We don't know how many terms there are, but we're told in part B that the very last term of this finite geometric sequence is 45,927. We know what term 1 is, and we know what term 5 is. We need to find term 2 and term 6. And so far, we know that we can use this formula because it's a geometric sequence. So that's the information that we're given. And we know term 1 and term 5. According to this formula, that means we know term 1. What don't we know? We don't know r yet. We don't know what the common ratio is. So one of the things that would be helpful to find term 2 or term 6 is if we knew what that r value was. So the question is, can we use the information that we have to find that r value? Well, I'm also given term 5. If you're just given term 1, it could be anything, because there's so many geometric sequences with different r values. But since we're given term 5 as well, what we can do is say, well, if I put in 5 for n, I know what term 1 is. Term 1 is 7. I don't know what r is, but I do know that n would be 5. And term 5 is equal to 567. 5 minus 1 is 4. If you divide both sides by 7, you get 81. Now, how do you solve for r if you have r to the 4? Square root would be what you would do if it was r squared. So what are we doing as a power 4? Fourth root. So if we took the fourth root of both sides, you would get r. I'd like you to take out your calculator, make sure you know how to do a fourth root on your calculator. And as a way to check, when you push enter, you should get 3. Okay, a couple of ways you can do a fourth root on your calculator. One is underneath your alpha button, there's a math button. If you click on that math button, they give you a bunch of different options. The fifth one there we go. The fifth one says x root, and depending on the version of your calculator, the newer versions will let you type in a little number 4 here, and then write 81. Some of the older versions, what will happen is you'll have to push 4 first, then hit the math button, go down to number 5, and when you do that, it might say 4x root, and it will put the 4 in there for you. So that is how you can write a fourth root. Or if you remember from last year that the fourth root of 81 is you can change roots to exponents. How do I write a fourth root? As an exponent of, not squared, not cubed, but 1/4. A fourth root is the same as a fraction. Just like you remember, a square root of 25 is the same as 25 to the 1/2. Do you remember that now? Or no? Yes? So now another way I could do is I could do 81, and then above the divide sign is this power button. The newer calculators will move your fraction right above there, so you can write 1/4 right in there as a fraction. If you have an older calculator that doesn't write it up small like this, you will probably need to put the 1/4 in brackets. So to have a power, you're going to have 81, and above the divide sign is the little hat, which moves it up. And then you can do 1 divided by 4 there. Excellent. So we find out that our R value is 3, and because our R value is 3, now for part A, if you wanted to find term 2, well, if term 1 is 7, and we're multiplying by 3, what will term 2 be? 21. You wouldn't even need to use a formula to find that out, because you're just multiplying by 3. You could have used the formula, because if you had used the formula, you would say, well, term 1 is 7, R is 3 to the power 2 minus 1, and this just comes out to 21 as well. Same thing, we got term 3, term 4, and then term 5 is 567. If you wanted to find term 6, you could either use the formula and plug in, I know term 1 is 7, R is 3, 6 minus 1, plug that in and find out what it's equal to. Or you could just take 567 and multiply that by 3. And if you multiplied 567 by 3, what do you get? 1701? Okay. Now something that comes up in here, and if you look at the bottom of your page, because they always have the answers to these ones at the bottom of your page on the right, you'll notice that they also list for term 2 that it could possibly be negative 21. And they also list for term 6 that it could possibly also be negative 1701. Now the reason for that is when we take the 4th root, just like when we take the square root of both sides, we made a little mistake here in that we didn't write plus or minus. Do you remember doing that when you did r squared equals 9? When you take the square root of both sides, you had to add the plus or minus, because negative 3 times negative 3 is positive 9, and positive 3 times positive 3 is positive 9. So whenever you're doing an even root, square root, 4th root, 6th root, you have to remember a plus or minus, which gives 2 possible values for our R value. Could be plus 3 or negative 3. Now, the last term is 45,927. Whoa. We know term 1 is 7. We know our, and I'm just going to put in positive 3 right now. What we don't know is how many terms there are. So we know the last term, and they want to say, it says how many terms. Again, just like with arithmetic sequences, whenever it says how many terms, you're going to want to find out n. Now, algebra here, what we're going to do first is we're going to divide both sides by 7. 45,927 divide by 7. Oops, 3. And at this point, we're going to use a technique that most people in pre-calculus do not like. Okay? You don't know how to solve for exponents algebraically yet. It's something you're going to learn in grade 12 using logarithms, but we're not going to do that right now. Because we know that n has to be a nice number. If this is going to work, this side has to equal 3 to the something. Thank you. So what we're going to do is we're going to guess and check, which is something that pre-calculus students tend to not like very much. It feels like we're doing a wrong technique. But for right now, that's going to be our best technique. And when I go to my calculator and I think of 6,561, any guesses, it's going to be 3 to the power, it's going to be bigger than 2. I hope you can see that. 3 to the power 9, so you try 3 to the power 9, and whoo, we got way too big, so now we'll have to go smaller. We're going to try 3 to the 8, and it works. So we go back here, and we say 6,561 is the same as 3 to the power 8. And just by observation, now you're going to tell me what n is. N has to be 9, because something minus 1 has to equal 8. N would have to be 9. So when you asked how many terms are there, there are 9 terms. So this step from here to here, what did we do? We used our calculator. And we used, whoa, that's not a very, and we used guess and check. If we were finding out how many terms, we know that n has to be a nice number. Otherwise, we can't have 9.5 terms to a sequence. So it doesn't take us too long to guess and check and find that value. Questions you can do for this one? Are 8, 9, and 11.